This begins our lectures on section 6.6, which is linear inequalities in two variables and systems in linear inequalities in two variables. We're going to, first of all, revisit the linear inequality in one variable, and then we're going to compare and contrast that to our linear inequalities in two variables. And we're going to learn how to make the solution set for a linear inequality in two variables, and then we're going to solve a system of linear inequalities, and then we're going to apply linear inequalities. So let's get going with what a linear inequality in two variables looks like, and then we'll go back to our linear inequalities in one variable and talk about those for a moment. So a linear inequality in two variables looks like a linear equation in two variables, except with the inequality in here, which it could be a less than, a greater than, less than or equal to, or a greater than or equal to. The a, b, and c are all real numbers, and a and b both can't be zero at the same time, and the x and the y's are variables. Solutions to linear inequalities in two variables are also ordered pairs, just like a linear equality in two variables, except for there's a lot bigger solution set. There's whole regions of the number line that we're going to be looking at as solutions for these things. So let's go back to a linear inequality in one variable briefly and talk about what we did to solve those. So remember that linear inequalities in one variable, we first of all are going to solve them just like we would an equation. That will be an important point. So here's our example A here. Let's go ahead and solve this one. So remember, we treat this just like we would an equation. So we're going to get the variable on one side of the equation and the constants on the other side of the equation. And then we're going to remove the numeric coefficient, and then we're solving that. X is greater than, 3 goes into 7 2 times, 1 left over, so we have a solution of x being greater than 2 1/3. So what this was, remember, was the end point, and what we do is we locate that end point. So here's the number line. I'll break this number line up into thirds so that we can more easily see it, just like that. And now we say the endpoint is at 2 1/3, so 2 1/3 would be right there. This endpoint 2 1/3 is not included, so I'm going to put a scoop on it, and then it goes off to this direction. So that's our solution. So we have interval notation, which showed us that, right? 2 1/3, and the scoop around it, the parenthesis, right, that shows us that that's not included, and it goes off to infinity. And that's how we solve these linear inequalities in one variable. And again, what I want to highlight here is the endpoint, right? It has an endpoint and then a whole lot of real number solutions. We're going to see that same exact thing come across in our linear inequalities in two variables. In fact, I'm going to skip the part B here with the compound inequality, and I'm just going to go right down to the linear inequality, and I'm going to talk about solving that and how it's similar. So if we have a linear inequality in two variables, what we're going to be doing is we're going to put this equation into slope-intercept form, and we're going to graph a line as if it were y equals ax plus b. Well, that right there is like finding this endpoint, because the line is the quote-unquote endpoint of the linear inequality in two variables. And then with the linear equality in one variable, what we had was from that endpoint, we had the solutions going off in one direction or the other. And with our linear inequality in two variables, that's exactly what we're going to have too. We're going to have some boundary line, right? Some boundary line in space, and then there's going to be a region of solutions going off this way or a region of solutions going off this way. And that's just like this line down here. So that's how the similarities are going to be. So now, with that said, what we want to take a look at is how to determine if ordered pairs are a solution for a linear inequality in two variables. Just like before, the way you do that is you do substitution. So if we take a look at the linear inequality in two variables that we have here, we have this linear inequality being substituting in for our x's and our y's and seeing if it's a solution. So why don't you go ahead and check those and see if there are solutions, and we'll solve those in the next video.